Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
So this is a very weird. We have seen that for n it's going to infinity, for 1 it's going to infinity, for 1 by n it's going to infinity. What happens like if you take 1 by n? So this is a this is something I'm telling you in advance, that for 1 by n squared, if you take summation of 1 by n squared and from 1 to infinity, this converges. The question is that bn is a partial sum I've defined before. I should have written Sn, but I wrote it bn here. Anyways, so the question is, it converges. You can show the partial sum converges. How I will tell you later on. The question is that therefore, so you see that n is very big, 1 is bigger, 1 by n is also big. So like, what is the sweet spot? Like, what is going on under the skin, right? So this is where we will coming. So the first behavior that we will see is something called divergent test. Okay, so what is this? That so we have got some special sequences series out here. So the thing is that it tells you the first property, that how sequence should behave for the sum to converge. The first property, that's the divergence test. So what's the divergent test? It's very simple. It tells you that see that n is there. So n should not be in the n is there, but n shouldn't be very large uh, in long-term behavior. What I mean is that shouldn't be. So the reason is why I'm saying is this, that observe that n is what is happening, that if you say n is equal to n, observe that the limiting point is very high. Like the limit of n is also infinity. So when you sum it up, it should be infinity, right? The an limit when n equal to n, the limit is also infinity, goes to infinity. So when you sum it up, it should of course be infinity, right? If you take n, when you take bit shorter, n equal to 1, the limit is not infinity, but the limit is large. So if 1 is being added a lot of times, infinite times, right? So n should go to infinity because infinity of some positive number is added, right? So it's like infinity time, like a positive number is added infinity times. So this tells you in some sense that even if you do n is equal to any small number, let's say 10 to the power minus 5 for all n, then also it will go to infinity because it will n times 10 to the power minus 5, so it will go to infinity. So in some sense, there is something like it tells you that n should be very small in the long term. How to denote it mathematically? So it's like, even if n equal to any small epsilon, for epsilon greater than 0, it will still go to infinity. You can I understand that the basic idea is n should be very small. It tells you the n should be very small in limiting format. Okay, now why is that so? So let's take an example, like let's say Sn is equal to summation ak k from 1 to n, and in that Sn converges to, let's say, a constant number L. Limit L. Sn converges to limit L. Okay, so you can imagine that since Sn converges to limit L, that means after a certain time point. So if you want to understand in terms of epsilon delta definition, or if you don't understand, try to understand in terms of the Cauchy definition of Sn, Sn minus Sm should be very small after a certain time point. For let's say n and m greater than or equal to certain n, and this tells you that summation of, like, let's say n greater than m, let's say this tells you that Sn is what? Sn is a1 plus dot dot am plus dot dot an, right, till an, since n is greater than m, and Sm is a1 plus dot dot am. So if you take the subtraction, you will get nothing but, this is nothing but mod of am plus 1 dot 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 summation of an. This is less than epsilon. Okay, for all n greater than or equal to this. So in some sense, you can see that that means in some sense the individual n will turn out to be very small. So there is a mathematical way to prove it. I'm not proving it's in the in books and all these things. I'm not proving it, but the basic idea is that this goes to this basic idea goes to that n is less than epsilon. Okay, it goes to the fact that n is less than epsilon for all n greater than or equal to this, and that implies that, observe that an is less than epsilon. That's exactly the definition of an is converging to 0 by epsilon delta definition. So what it means mathematically is that, as rather, if you just take so instead of, what you do is simple stuff. You just take n to be m plus 1. If you just take n to be m plus 1, this turns out to be just am plus 1. That means for all am plus 1 is less than epsilon for n greater than or equal to n. That means in some sense that an, like it's exactly what it means that an is going to 0. It's we are using the Cauchy definition of this. Okay, an is going to 0. That exactly what we mean, that an should be very small. If an is going to n, let's say 0 point, let's say n is going to 0 point, even not, let's say 0.01. That means in the long term it's going to 0.01. So that means long term, if all of them should be around a small epsilon delta region of 0.01, let's say 0.09 to 0.011. During this, after a certain time point, all of them will be lying in that. Hence, you can say that all of them after a certain point will be greater than this, which is a very small number. It will be infinite of them, so it will be going to infinity. So therefore, it must go to 0 at, like, it doesn't mean the other way around. It means that if the series converges, the sequence, like series of an converges, then an must go to 0, not the other way around. All of you understood this? This is what divergent test tells you. Did you understand? Any doubt? If you have some doubt,
So
please
can you
tell me.
please tell me from sir where you have drawn sir 0.01?
Yes, the basic
Which
idea is
number line?
understand. Let's say an is going to 0.01. So therefore, what it tells you by sequential definition, I hope you have seen or watched the sequence video. You must have watched that. That is expected. That is required. That after a certain time point, let's say n epsilon, where epsilon is equal to 0. Let's say 001.
Yes sir.
After a certain time point, all the sequential elements will be lying inside this bound. That means L, this is the L, so L minus 0.001, that is this one, and L plus 0.001, that is this one. That means after a certain time point, all the sequential elements will be lying inside this. So that means if you can see k from 1 to infinity, you can divide it into, let's say k from 1 to n epsilon. At this point, whatever happens, this is finite number, doesn't matter. But after this time point, k from n epsilon plus 1 to infinity, all of them should be greater than 0.009, because that's the lower bound. Because after a certain point, all of them lies inside this bound, right? So therefore, whatever this number is, this is this times infinity, because infinity of them are there. All of them are greater than or equal to 0.009, and infinity of them are there. So this is a finite number. This number is a finite number because finite terms are there, and this is going to be infinity. So essentially, the entire thing goes to infinity. The only way it can not happen is that this limit can go to 0. Then positive, negative may cancel it out, but not always. Did you understand? It's
Yes.
like a necessity condition that it must go to 0. Like that must happen at least. Did you
Okay.
understand, guys?
Yes sir. Thank
All
you
of you
sir.
understood? Yes or no? Any doubt? Please tell me. Okay, thank you. Great. So, but this is not a, so the converse is not true. Converse is not true. Like an example is like, if an goes to 0, does not mean that summation an will converge. And a very big example I gave you in the beginning, that an is equal to 1 by n. You can see that this goes to 0, but summation of an does not converge. So what it essentially means, but for example, an is equal to 1 by n square, it goes to 0, but summation an converges. So what it intuitively means that an should not only go to 0, plus an should go to 0 very fast. An should not only go to 0, but an should go to 0 very fast. Like 1 by n square goes to 0 faster than 1 by n. So 1 by n ka graph is like this. 1 by n square ka graph is like this. Sorry. Yeah, let's take it 1. So it goes faster. It goes faster. And this fastness has something to do. We'll talk about it soon. What do you mean by faster? What do I mean by faster? Like why fastness matters of the graph? Why fastness of convergence matters? One example of fastness is this, that another example of sequence is, let's say, e to the power minus n, or to any constant to the power minus n. C is greater than 0. So understand that summation of n or ak from k from 1 to n, or if you remember, this is the GP series. It's nothing but c minus 1 plus c minus 2 plus dot dot. It's nothing but c to the power minus 1 times 1 by c. It's c to the power minus 1. It's nothing but, yeah, c should be greater than 1. So c minus 1. Yeah, it's c minus 1. So you can see that this, let's say 1 by 2 to the power n. Let's say c is equal to 2 to the power n. Let's say it's like, you can understand that it goes to like this. If you compare, if 1 by n is like this, 1 by 2 to the power n is like this, 1 by e to the power n, or like 1 by 2 to the power n, like, sorry, this is 1 by n. The red one is 1 by n square. The blue one, the like 1 by 2 to the power n will be really like this. So essentially, what my idea is that fastness. So this doesn't converge, but this converge and this converge. That means the fastness of convergence, how much it's going to converge, how fast is going to converge to zero. We will make it mathematical more. Convergence to zero matters. All of you understood this basic idea? That it doesn't matter not only how it's going to zero, but also it matters that how fast it is going to zero. All of you understood it?
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.